So, angles and transversals. What we need to remember is what parallel lines and transversals are. So, parallel lines can be shown to us by using arrows, remember? So those tell us that those are parallel lines. If we have a set of parallel lines and then we have another line that cuts through it, like this one right here, that is called the transversal. Okay, so the line that cuts through parallel lines, they are called transversals. And we're going to be looking at the angles that these transversals create. So the first type of angle that the transversal can create is the corresponding angle. Now the corresponding angles are of course created by the transversal, and the corresponding angle we can look for the letter F. So if we're looking on this diagram right here, I've got my little F right here. And the two angles that we call corresponding are the angles that sit underneath it. But we mustn't just be stuck in the F in the one fashion. We could even have the F going backwards. You can't really see that. I'll do red backwards. Or the F could be upside down, meaning the corresponding angles are here. Or backwards and upside down, meaning the angles are here. So we call these corresponding angles if the angles are underneath the two sections of the F. The important thing to note, if the two lines are parallel, then these corresponding angles are always equal. So even if the lines are not parallel, the lines are like this, we still call these the corresponding angles, but because they're not parallel, they would not be equal. In this diagram here, these are parallel lines, and so therefore the corresponding angles are completely equal to each other. So that's our first set. Let's have a practice with that. So in this one, it wants me to calculate the value of the missing angles. So I'm looking for the F. So my first F that I've found here is an upside down one here. And here's the one angle, and here's the other angle. Now, I can see that these lines are parallel to each other because of these arrows. And what I'm going to do is know that if I'm using corresponding angles that are on parallel lines, they're equal to each other. So I'm going to write here the little F for the F rule. And I'm going to say this one, I'm going to give it a letter B. B equals 110. Just like that. That's how easy it is. So if I know my corresponding rule, I can just write it, the answer. Here's my other F, and this F is upside down and back to front. So these two are corresponding. And again, I'm just going to write a little F so that my teacher knows that I know the corresponding rule. And I'm going to call this C. And I'm going to say C equals 70 degrees. That is how simple it is to find the missing side with corresponding. I just want to quickly show you here how we can sometimes get confused with the F. So sometimes you're like, oh, I can't find an F here. But we need to make sure that we are looking from all angles. So in this situation, I can see the F here going out to the side. So these would be corresponding. And even I can find a backwards F going this way. So these would be corresponding. So we mustn't get stuck in thinking that an F has to be straight like that. We've got to think of all the directions and all the angles that it could possibly go. So that are corresponding. The biggest thing with these ones is not necessarily having to calculate things, but just know what the angle is called. So these are corresponding. Next up, we have alternate. So again, alternate lines are formed when there is a transversal, so this is our transversal right here, and we have to look for Z. Okay, so in this example, we have the Z right here. Now these angles that are on the two corners of the Z are called the alternate angles. And in the exact same fashion, if the lines are not parallel, we can still find the Z here, and these would still be called alternate, but they still have the name alternate. But if they're parallel lines, then the alternate angles are always equal to each other. So we can remember, if we can find parallel lines, then the alternate angles, which we can find using the Z, will be always equal to each other. Now Z's a bit easier because we only have two combinations of Z. We have front Z and we have backwards Z going this way. So let's have a bit of a practice with our alternate rule. So once again, I've got these lines. These two little arrows tell me that they are parallel. And so I'm just going to use a little Z to signify to my teacher that I know the alternate rule. Then I'm going to try and find the Z here. Here it is, right there. So there's one, there's two. And my alternate rule with parallel lines tells me that the angles are exactly the same size. So I'm going to call this one D, and I'm going to say D equals 44 degrees. Simple as that. All I have to do is look at it and identify what is the angle size. Let's try one more again. This is on a different angle. So I can still find my Z here. Okay, and now these are parallel lines, so this one is going to equal 70 degrees as well. And my other Z is the backwards Z. Parallel lines, this is going to equal 110. That's how simple it is. We just got to look. Don't have to calculate anything. Corresponding and alternate are just equal to each other on parallel lines. The next one that we have with transversals is the co-interior angle. Co meaning two, interior meaning inside. So it's the two angles inside. We can look for the letter C, or sometimes it looks like a U. But basically, it's the two angles that are inside the box. Again, if the lines are not parallel, we can still have co-interior angles. But again, if the lines are parallel, the two angles inside will always add up to 180 degrees. Always. So if these lines are parallel, the two inside angles will always add up to 180 degrees. So let's have a bit of a try. So here I've identified my C. So I'm going to write here for my teacher the C rule so that they know that I know co-interior angles. Now I have to do a bit of calculating. So the total value is 180 and I've used up 50 degrees on this angle. So I'm going to take away 50 degrees. That leaves me with 130 degrees left. And once again, I'm going to give it a letter. You will be given a letter, so don't worry about naming the letters, but E equals 130 degrees. The really important thing here that I want to point out in this diagram is that obviously this is not a 50-degree angle. It's an obtuse angle. It's not 50 degrees. The really important thing to note is if you're told a piece of information like 50 degrees, even if your eyes are saying, that doesn't make sense, that can't be a 50-degree angle, we still believe the information we've been given, and we just assume that the diagram is not drawn to scale. Always trust the information you're given over your eyes. because we can trust our eyes, but sometimes the diagram is just drawn for us to solve a problem. All right, let's try one more. Finding the co-interior angle. Oh, I found a backwards U like that. So I've got, again, I'm going to do my symbol so my teacher knows that I know my co-interior rule. I know that the total is 180 degrees, and I've used up 15 degrees. If you need to do it like this, 180 take 15, that's fine. You can do that way as well. I'm going to do it that way for this question. 7, 10, 10 take 5 is 5, 7 take 1 is 6, 1. So I'm going to call this F, and F equals 165 degrees. So that is how we do our co-interior angles. So let's quickly look at all angles with a transversal. So we have our corresponding angles. Our corresponding angles, we're looking for the F, and I have the 4 examples of the F here. We have the straight F, we have the backwards F, we have the backwards upside down F, and we have the upside down F. Okay? And we're going to remember that on parallel lines, they're equal. Okay? It's that easy. If we have parallel lines, corresponding angles are just equal to each other. Next, we had alternate angles, and we're looking for the Z. And here we have a normal Z, and we have a backwards Z. And if it's parallel lines, they're just straight equal to each other. Again, super easy, just completely equal to each other on the Z. Lastly, we have co-interior angles, and we're looking for that U. We're looking for that U like this, or maybe even sort of like an N like that, or a C like that, or like a backwards C. That's the shape we're looking for. We're looking for the 2 angles that are inside those lines. And again, if it's parallel lines, then they add to 180. So we can add them up to equal 180. So those are our 3 types of angles formed by transversals. Remember, a transversal is a line that cuts through 2 other lines. And those are the 3 angles that we can do. I hope this has helped you to figure out how you calculate those different types of angles. Well done for sticking to the end of the video. Here's a little picture of my puppies as a little reward.